Thank you very much. It's been a great turnout today. There's only been a couple of meetups since we've had a group this large. Really pleased to see as well that there was about 20 odd of RSVPs for this session that were new members. So if you've not been here before, welcome. Everyone here is very approachable. Hope you have a good time. If you've not been to the venue before, toilets are on the far wall over there. If you need anything else, just ask. Everyone's happy to help out. If you don't know me, I'm Christian Southall. I'm an organiser of the user group, and I'm really pleased to welcome our friends from AFG tonight to talk about cloud-native platforms for rapid development. We're making an assumption that not everyone, is well versed in the theory and structure of these platforms. So I thought I'd take a few minutes tonight just to introduce the topic, talk about a couple of the patterns and architectures, and just set the scene for the AFG chaps. Okay. So platforms are foundations on which we build, leveraging the work of others to shorten the path to our outcomes. They're not only a feature of information tech, they happen in a lot of industries, but in our space, public cloud platforms are a domain example of these things par excellence. However, despite the fact that there are literally hundreds of services that are available to you, they don't do what you need straight out of the box. You don't just log into a console and start doing business. So this is why you need your own cloud platform. To eliminate that toil of deploying, hosting and managing your workloads, to allow you to get on with the business of doing what it is that your organisation does. So I'm just going to put up a bit of a reference architecture here. We've spent a fair bit of time thinking about this at Journey 1. So this model goes by the name of FlyOps. It has several iterations, but we'll look at a version tonight. Central to this whole exercise are your workloads. I mean, I've got some generic technology names there, but I mean, imagine they are true business applications. They're moving your data between systems, they're allowing your users to interact with your data. And we could build all of those just using AWS Foundation services. Compute, storage, networking. I'd argue it'd be foolish, but we can do it. Instead, what we tend to do is move up this value stack to use some managed infrastructure services. Get rid of some of that undifferentiated heavy lifting. Spend less time configuring our infrastructure, more time building good stuff. And if we're particularly good, we might even go up another level of abstraction and look at some of the platform services. Serverless services, for instance, might fall into this category. But as our estate gets more complicated, more workloads, more environments, more users, we need ways of managing that complexity. And AWS introduced us to a concept called the landing zone at that point. It's an industry term. I'd argue it doesn't get bandied about too often in the literature. But anyone familiar with the control tower service has probably come across this term landing zone, which in its basic formulation is a multi-account infrastructure for managing your services and their configurations. However, like those underlying services, the landing zone's not doing business for you. It's helping you manage the cloud infrastructure and services, but it's not really getting you to your business outcomes. And this is where your platform comes in. Sometimes I often call it a cloud operating platform. AFG are calling it a cloud native platform because there's a particular nuance on that. But we'll call it your cloud platform for tonight's purposes. And there's a few ways we might slice and dice how we create, how we instrument our platform. There's going to be a set of operational services running the basics of what is there. There may be some development services helping you create workloads and deploy them to your platform. This is a slightly interesting category. There might be some hosting and infrastructure services. So where are you going to put your workloads? And there are cases sometimes where we're not all the way up that abstraction stack, and we do need a GPU-enabled machine to do a little bit of playing around, in which case some self-service infrastructure can be a useful thing to have. But similarly to that stack, moving up from the foundation infrastructure to platform services, there's a similar value proposition on your platform, moving from the more operational services to domain-specific services. Common things that you do in your organisation that could be built on the platform and reused across workloads. So we'll just drill in to that layer just quickly now. So what are some of the things that compose that operations services? So an account and organisation management. So how do we link up a set of multiple accounts? How do we create them in a hierarchy that gives us the ability to manage them? How do we apply configurations at that account level? This is something that AWS organisations is typically used to do, but there's a whole number of configurations that we might apply to manage those entities. Similarly, identity and access management. There's a number of ways to skin that cat on the platform. When we go to build a platform, we have to make a choice. We're doing a trade-off of what features we need for the work that we can put in right now, and that will evolve over time, hopefully. But nonetheless, we need a way of identifying our users and controlling their access to our systems. Similarly, security management. Can we set up some guardrails? How are we going to prevent security incidents from occurring? How are we going to know that we are non-compliant with our security standards? Resource management. So, okay, we've created a multi-account infrastructure. We've got hundreds, thousands, maybe tens of thousands of resources distributed across all of these things. How do we know which ones relate to other ones? How do we find things that have been deployed perhaps by disparate teams that might not always be talking? We need strategies and service configurations that allow us to group those resources, be it through tags or AWS config or a series of options. We're not all operating purely in the cloud or in one cloud. So we need to connect our sites. This is a critical enabler for particularly new services. Again, there's a variety of solutions we might use here, from the internet through to VPNs, through to direct connect. It depends on your use case. Most of us don't have the luxury of operating in a purely serverless environment. We still have network-addressed resources. We therefore need networks, and particularly if we're integrating with on-prem and other cloud networks, that can lead to some relatively complex configurations. Not the kind of thing you want your developers to be dealing with. Put it in the platform. Logging and audit management goes without saying. Data retention and disposal. There are things we can do platform-wide to make sure that data is retained and disposed of appropriately. We want to operate our automations, and critically, we need to manage our spend. We need visibility of what we're spending, like by the hour, ideally, and we want to be informed when we see anomalies. Any number of configurations we can do, but it can't be ignored. I'm not going to go too much into development services. We've only got a few minutes. I want to leave time for the AFG chaps. But these domain services are really important. So I'm just going to throw up some examples because I don't know what businesses you all work in. I was working with a client this week in the medical research space. So we were having a chat about what some of their platform services might look like. A critical one is out there on the right, research engagement tracking. This is a key performance measure for that business. They run a number of research projects, and the extent, the frequency and number of times that data is used by end users, by other researchers, is the kind of metric that leads to them getting more work. It's a classic case for something that all of their projects need to do. Perhaps it belongs on their platform. Landing zones have had a bit of a history at AWS. AWS Organisations was launched in about 2017, so this was the first time that we could do multi-account management. It gave us consolidated billing, so we could roll up our bills to one account. It gave us service control policies, so we could apply security controls policies from the top level down to our leaf accounts. And it gave us cross-account access using roles. That was further supported by a solution, not a service, an AWS solution called Accelerated Landing Zone in 2018. It's totally deprecated now. Don't go anywhere near it. It's unmaintainable. But it was a very important sort of experiment at the time. It was an unwieldy, massive CloudFormation template with inline code. But it gave us some really important features. So it gave us SSO and the ability to use credentials. So with SSO, we only had to know one set of credentials as an individual to log in. We could assume any number of roles that we then needed to get to our other accounts. And the credentials that we were given to access those accounts with those roles were ephemeral, right? They were time limited, which is far more secure than the permanent credentials we get with IAM users. Account vending was also another critical feature that was given to us. So that's the ability to automate the creation and closure of accounts. In 2019, we got Control Tower, which gave us a much better, stable, and now fully supported AWS service implementation for doing this multi-account management. It did take a bit of a step backwards in terms of configurability. The accounts weren't quite as customizable, but it was fully supported, super stable, and remains so. Really, it's a wrapper service for a bunch of others, AWS organisations and config and CloudTrail and a whole bunch. And tonight you're going to hear about what's probably at the leading edge of this landing zone technology, which is something called Landing Zone Accelerator, which actually takes its cue from the old accelerated landing zone, but is a far improved implementation, far more maintainable. It's been open sourced, and it is now fully supported and generally available. Accelerated Landing Zone was actually only deployable by accredited partners, so it never quite had the wide adoption. But Landing Zone Accelerator is incredibly powerful. It will deploy huge numbers of resources in relatively small amounts of time if you know how to configure it, but it does have some drawbacks, and I think we're going to hear a bit more about that later. Dropped out. Very quickly, we can think of these cloud platforms as existing on a bit of a continuum. From minimal configurations with some of the basics that we typically need, account vending, consolidated billing, service control policies, some basic cost management, SSO, that's kind of almost non-negotiable. I mean, that makes our lives a lot easier and our operations far more secure. But moving along this line, we can get into these general purpose platforms. I think one of the key distinguishing factors here is we start to implement site connectivity and network configurations, particularly funnels where we'll channel all of our traffic through a single account so that we can apply quality of service and security controls and all of those kind of good things to our network traffic. And we're also likely to see more sophisticated cost allocation and containment strategies when we start moving along this continuum. That continues into a sort of more advanced general purpose model where we may have a lot of self-service capabilities for our end users, and particularly account customization. So this ability to treat accounts as products and have sort of multiple configurations. If we create an account under a sandbox infrastructure, it gets created with a certain set of resources by default, as opposed to, say, accounts under a security group. At the far end, though, we have these domain or workload-specific platforms, far more sophisticated, not really the place to start. This is where AFG are now. We're going to hear a really great story about this tonight. You're going to learn a lot about it, but the message that I'd like to leave you with is if you're not over there yet, if you haven't spent a decade in the cloud, you should start at the beginning, and it really is where you should start. If you need to know more about that, we've travelled a fair bit of ground in a fairly short amount of time, but we do only have one evening. Do let us know. We can do more of this. We can expand upon this more in future sessions if need be. But with that, back to you, chaps.
Worked perfectly fine earlier when I plugged it in. Just a shove.
Gotta plug it in.
Yeah, excellent. Good to have IT support.
Okay. Back in the day, maybe.
Yeah. Let's just get that up. Cool. All right. And my clicker. Cool. All right. Thanks for that, Christian. And hi, everyone. My name is Mick, and I manage the cloud engineering team at AFG. So I'll do a few intros, but very quickly, I'll tell you the story in 1 minute. And the story started exactly a year ago. We were in a position where the cloud engineering team had probably our biggest ever challenge. We've been on the cloud for 10 years, but our cloud platform evolved in a certain way, probably maybe like your own organizations, where we had a few different accounts, but they were all different. There was no common way that we built things. And one of them in particular had grown to be colossal. It was huge. We had a very big monolithic application in that account. It was the center of the world. It was integrated to pretty much everything else in the environment, and it was integrated to lots of third parties, and it was out of date. But we had a huge big program to replace it all and to break it down into lots of little services. That was awesome. But we needed lots of AWS accounts to support that. We needed new security tools, security standards. We needed tools for developers. We wanted to adopt CDK and allow developers to build infrastructure for the first time. And there was a lot that we had to do, and we needed to do it kind of yesterday. So we were in a bit of a jam. And thankfully, we engaged Journey One, and they helped us quite a lot. But what we were able to do by the end of last year, we're just reflecting back on it today, to be honest, kind of for the first time, and pretty proud of it, I guess. We've come a long, long way in a short space of time. And by the end of last year, we got into a position where we had built account vending. We are able to spin up accounts very, very quickly. Accounts that are secure, all guardrails built in. The developers can build their own infrastructure, deploy using CDK and other technologies. We had to build a very complex and extensive core network. We managed to do that as well. And again, heavily leveraging landing zone accelerator and other tools. So that's the very quick version. So we'll go through that in a bit more detail along with the guys. So yeah. Thanks to Christian, you've already met Christian, but the wider Journey One team were very much involved on site, working with us for the entire project. So we'll delve into that a little bit more. For myself, look, I've led a variety of different teams, software development teams, infrastructure teams, in a few different industries now. I worked at INET and Bank West, but I've been with AFG for the past 4 years. That's been pretty exciting. And today we've got Liam Hughes. So he's our solution architect. And now Liam is a long-timer at AFG. He helped establish the cloud engineering team in the beginning. Very hands-on, very experienced with AWS. And he was the lead architect on the project with a big focus on the core network. And then we've got Levi with us as well. So Levi is our most senior cloud engineer at AFG. He's our guru, go-to person for anything related to Puppet or Linux or Sumo. And then on top of that, he took on the lead role of working with Journey One, building, designing, testing, and operating our cloud native platform. So yeah. Okay, so just to give you an idea what we'll go through. First of all, I'll just explain who AFG is. I'm guessing most people are not familiar with the company, who we are, our industry, and then I'll give you a bit of a view of that 10-year journey on AWS up to the point when we started the project. And I'll hand over to Liam. So Liam will give a bit more of a technical dive into our tech strategy overall, what we were trying to do, and I'll give you some insights into that core network, which was pretty fundamental. And then finally we hand over to Levi, and Levi will give you, show you exactly kind of how we adopted LZA and what that experience was like, good and bad. Cool. So, has anyone heard of Australian Finance Group besides the people in the room that I know? So, we're a relatively small company. We're based in West Perth. We're a mortgage broker aggregator. I'm guessing most of you either have a mortgage or you will someday have a mortgage. And two things I would say about that most people know is that applying for a mortgage is complicated and having a mortgage is expensive. Right? So one thing I would strongly recommend if you go through the process or you go through it again and again is use a mortgage broker, because a mortgage broker, first of all, are free. And they can help you navigate, the many different lending institutions that there are in Australia. It's not just the big four. AFG alone can help you get loans from 80 different lenders. And every single lender has lots and lots of different products. So again, just through AFG, there's like over 9,000 loans you could look at. And you're never going to be able to look at them by yourself. So a mortgage broker can help you. If you shop around, you get the best deal. Okay, so that's our pitch, that's our company, that's what AFG has been doing for 28 years, and that's kind of our mission statement, is trying to get a fairer deal for Australians. Cheaper mortgage, hey? Who doesn't want that? So, give you a bit of context, mortgage brokers, they're our customers. So we build our software systems to help them so that they can run the business. Your typical mortgage broker needs to have CRM tool to manage all of their customers, help them do a home loan application, and there's a lot of work in that, a lot of documents, a lot of paperwork, and then submit that to the loan and hopefully get it approved and get a house. So we build in-house. We've got multiple software development teams and security and cloud engineering, so we're a fully fledged IT shop building out our own solutions, and we've been hosting them on AWS for quite a while. This will give you context on that, I guess. So obviously AWS itself has been around for quite a while, but we were relatively early adopters. And this slide, this graph just shows AWS's own growth and trajectory, and it just gives you a sense of when we adopted. I guess AWS was objectively smaller back then, and it did have less services, and that meant that when we adopted AWS, some of those things that Christian mentioned, some of the things that can help you organize your real estate and your accounts and so on, they weren't available to us at that time, which was part of the reason why we went down certain paths, made certain decisions. And actually beyond that, even when some of those tools became available, we actually had, we use AWS through a reseller, so we didn't have access to our management account, to AWS orgs or Control Tower and all those kind of good tools. We only got them very recently at the time of trying to adopt this. So yeah, we started back a while ago. And like everyone does, we started small and simple, you know. But we also started with best practice in mind. And this is, you know, a nod to Liam and to my predecessors long before me. But from the very start, it was about best practice, trying to do things in a highly available way, security in mind, everything automated, infrastructure as code. So a really good start in our journey on AWS, and which meant it was very successful, and very quickly then it was kind of all in from AFG's point of view. So the idea was then, yeah, everything we build goes onto AWS. All the stuff we already had in the data center goes onto AWS. So as these things go, story over 10 years, we started off small and simple, started to grow, it got bigger and more complex, until eventually it got very complex. And you kind of wonder, well, what does that look like? I asked AI, and this is what AI said, so still a little bit edges to be worn off the generative AI, but you know, this is, so just give you an idea, right? So we started off small, but early on, we put our core business application, our CRM system, developed in Oracle Siebel, so it is fairly old technology, but we put that onto AWS. And like I said, that dictated a lot of things from there. A lot of integrations. We had to really increase the number of AWS servers we were using, you know, so our VPC got very big and complex, a lot more DNS, we had peering, we had direct connect back to other Oracle services and on a different cloud. So it just grew and grew and grew. And it got to that point, like I described, where it was quite difficult to quickly add new accounts, because we've done things in a mostly bespoke way each time. So that's where we were. So yeah, so what made us, you know, change strategy and where were we a year ago? Well, there's a lot of things happening in our industry, in our markets. We're certainly feeling a lot of pressure from our customers. So a lot of the brokers that we serve and provide systems to, they were starting to adopt other technologies, you know, so there was real risk. We needed to stay up to date. And that particular monolithic application, you know, it's a bit old-fashioned now, UX not great, a lot of duplicate data entry, those kind of things, and that was why the other brokers were kind of, you know, adopting other tools. So we had to pivot, and we had to come up with a new strategy. Well, like I said, some of those technical issues, we couldn't quickly and easily adopt the iterations, the landing zone that would have probably helped us back then. We had tried, and I had some success in moving up the stack and adopting serverless. But again, when we did that, it was still deploying Lambdas into that same large, complex environment. So we never gave the keys of the kingdom to the devs. We kind of kept control where we were, you know, we became effectively the middlemen between the developers trying to build their applications and get them running on AWS. The small cloud engineering team was still right there in the middle, holding hands, afraid of giving too much access to developers, because that blast radius could have gotten us into a lot of trouble. So, you know, we needed to move away from that model where cloud engineering was building everything with CloudFormation and Terraform, and adopting some new tools like CDK that would enable the devs to do their own building. So yeah, that's kind of where we were about a year ago. Hopefully that gives you an idea of who we are, what AFG does, and our journey on AWS. So I'll hand over to Liam now, and we can go into our tech strategy. Thanks.
Cool. Thanks, Mick. Cool. So, as Mick was saying, our industry had changed like quite a lot. So, our tech at the moment, or at the earlier time, was probably 10 to 15 years old. Our CRM was in an interesting state. A lot of our other competitors had sort of built out new tech stacks and sort of just progressed past us. But even then, once we saw what was happening in the industry, it kind of changed our minds a bit. So we started to see all these little bespoke tools that would come up that brokers would start to use rather than the big aggregators CRM. So all these little niches that would do one specific thing rather than doing everything. And they got really, really good at it, and the brokers really like those tools. And we just couldn't compete with that type of thing where they were spinning up these new features so fast. So our CRM, we spent 1.5 years or 2 years almost to upgrade it, and we didn't really give anyone anything new. And we also spent a good 2.5, 3 years to try and replace that with new tech, and in the similar sort of principle of building another big monolith, and that just didn't go anywhere. So we've had quite a lot of time with nothing really to show for our customers. Like, yes, we've given them a better platform and a more stable platform, but from what they're looking at, it's more or less the same kind of thing, where it's this big monolithic CRM that they use as a data entry system. So there's lots of new stuff out there, and we just couldn't really use it. We found that it was really hard to start to integrate some of those into our current systems. In a big monolith, you get a lot of risk when you start to integrate all these different players into it, because if you change it, you're going to be risking affecting everything within that system. So all your data models have to be the same, all your integrations have to all sort of work together. So we really wanted to move away from this big monolith system and start to work on integration to these third parties, but also splitting up our monolith into smaller parts that we could actually manage in a realistic way. So having a lot of learnings from our time in the cloud over the past sort of 10 years, and Mick alluded to about that big account that's got everything in it, we really wanted to make stuff smaller and not have a bit of spaghetti going everywhere from systems to systems and all within one account. So we really wanted to go down an actual structured method and a structured approach of deliberately designing these systems to do what we wanted them to do, but also apply it in a way where we can contain them. So the biggest thing that we really learned was around the serverless stuff. So all the serverless stuff that we had was all in that big one account, and all overlapped, and every time you wanted to do something, you had to figure out, well, was it just going to affect that one service that you're doing, or am I changing an IAM role that's attached to 5 different services, and if I delete this permission, I'm going to blow everything up. So we really wanted to make sure that we didn't go down that path again with serverless, but we really like the idea of having small bespoke things that you can just spin up and you don't have an operating system to worry about. Like, that's really, really cool to do. Yeah, so the other one as well was the account itself had so much stuff in it. So we had our core CRM, we had about 5 or 6 different serverless applications, WordPress servers, like Tomcat, like you name it, we've got it in this one account. And we realized very quickly that we can't kind of hand that off to anyone. It's got to be one team that manages that account, because if you don't have that one team doing it, you're basically opening that account up to everyone who has access to it. So the CRM team could play with serverless stuff, the serverless teams could modify your CRM, and it just becomes so much risk. So you've got to centralize that in one big account. So we wanted to separate our accounts as well, because like we needed to be able to get more than just the cloud engineering team to actually maintain all this stuff. The other couple of things that we did when we started to look at this was focusing on the DDD concept, so domain-driven design. If you've heard of that, really cool stuff. They talk about how you can structure your systems around your business context rather than like what they actually do. So we came up with a few core business domains for our company and what we can do. So things like a broker is a domain. All the data about the broker, who they work for, what their name is, what their email address is, like if they're compliant within our systems to be able to do what they need to do, that would be one domain. And then separately to that, we've got products, where all the products that the lenders give us go into this other place, and basically you've got all the calculations about a product. So you've got these 2 different domains that we got other ones in there as well, but that was kind of one of the ways we started to separate our systems, was trying to understand how the business would actually use and integrate with these systems and separate it out. It also helps with the management of them. So as soon as we start to grow the teams and split up who does what, you can start to build out these focus teams to say, you're a broker team, you deal with the broker as a person, as an entity. You can start to work with the onboarding team to say, well, how does the onboarding team want to interact with this system? Same with products. You start to talk with the lenders and say, well, how many products are you going to bring on? How are you going to give us these product data? You start to get different contexts within in teams that actually do these systems as well. The last one is the focusing on systems that we wanted to make sure they focus on what they needed to do. So if you imagine a three-tier application where you've got like a web UI, you've got an API backend and a database sitting behind it, like the standard three-tier structure, right? Your web UI is focused on your interaction from your client and who actually is using your system. So you want to have it nice and snappy, you want to have it look pretty, you want to have buttons that do the right thing. You've then got the API, which is more or less your brain that receives the data and does stuff with it, and then your database, which is storing it all. You really don't care what the UI looks like from the database perspective. Like, you don't want your data model to be what the user is interacting with, you want sort of a separation of it. So we kind of took that thought approach where we wanted to make sure that the systems that we built focused on what they were supposed to do. So we don't want a database that has a brain because like it's storing data. You want to optimize it for the storage of data to be able to get the right queries to it and work in a certain way. But you don't want that in your UI. You want your UI to be operating with data very differently. So we sort of took a bit of that sort of approach as well. So what we kind of came up with was a bit of a tiering structure for our systems and what we wanted to actually implement. So at the top we've got consumers, which is the people interacting with our systems or systems interacting with our systems through APIs. At the top we've got the public layer, which is kind of your UI style interaction where it's like this is what we expose to the world to say, come use our stuff, this is what it looks like, this is what it does, these are our API integrations. They're very specific for an access layer, not really a brain layer. And what they do is they orchestrate functionality across the domain tier, which is the next one down. And that's where we store business logic and data. So your more API and database kind of structure will sit in there. And that's where the core business domains come in that actually do things and do work. So they're the ones that you would send an application to send it to a lender, or they would produce a list of products that meet a filter criteria. And then the public tier above it just orchestrates that between the domains. So a great example is if a broker is compliant where they're allowed to lodge an application, we've got to check that first. So we go to the broker domain to say, are they compliant? And then we send it to the application domain to say, send the application now. And then the last one in our services is the supporting tier, which is just common services used by multiple domains. So you're thinking like, if we've got to generate documents, we only want to write that once. We don't want to have 5 different ways of generating a document. So all the domain tiers just consume our document generation supporting service. Similar with integrations, so integration out to a supplier, we go through the supporting tier, and then that goes out to things that you use to enhance our functionality, so lenders or, trying to think of another one that we've got. No. Yeah, so just all sorts of stuff that we would use to consume, to add stuff that we don't necessarily want to build ourselves. So that's really our structure that we built, that we designed, and then what we've got here is how we actually implement this in Amazon, and it shows a bit of the complexity around how we do things. We really focus quite heavily on serverless, so we don't build EC2 in what we've got here. We start with API gateways as our single entry point. So there's one API gateway that a system is, so that workload box on the left is an Amazon account with one system in it. We've got one API gateway in there. And within that, we've got a VPC with lambdas, and then the bottom box is the transit gateway attachment, which I'll get to in a sec. We then got serverless things in that, so S3, Dynamo, SNS, EventBridge, Secrets Manager, like all of the platform services and the nice things that Amazon give you for free, well, not for free, but you don't have to build them yourself, you know what I mean. So basically, it's like a self-contained block that we can pick up and move around and do whatever we want. But we needed to structure it so that we had controls around what they could do. So on the right-hand side is our network design. And what we've done is the public tier is sitting at the top, which is internet accessible. That goes through transit gateway and a VPC endpoint to a private API gateway sitting in the domain tier. So our domain, our core business logic and all of our data is not internet accessible. You have to go through our public tier to get there. So we get to control all the access at the public tier, all the orchestration to our services, and protect our core domain. From there, you can't get out to the internet. So that's where the supporting tier comes in, is that we go again through transit gateway and VPC endpoints into another private API gateway, and then that can access the internet out through the internet gateway, through the transit gateway, and centralizing the egress. And that gives us the outbound protection from the domain service to make sure that whoever builds it, you can't go out to the internet. You're not allowed to. You've got to do that in supporting tier. So you've got to talk to another team and another way of doing things. So it's not allowed to sort of break the pattern. We found it like a really interesting way of doing it and using the private API gateways to link serverless services together and building out these individual systems and then structuring them in a way that gave us confidence that we can't get around it. The other half of this as well is all the other bits and pieces that sort of fit within Amazon and the lovely things that you can do. So this is a bit more of an explosion around one particular bit. So on the left-hand side, we've got our environments of the workloads, which was that diagram on the right before. And then what we're talking about here is the shared services access. So because the domain tier can't access the internet, we still want to be able to access your parameter store, your secrets management stuff. And if you can't go out to the internet, how do you do that? We use the Amazon VPC endpoints to do that. And what we did was we centralized all of that through all of our environments for every API gateway, for every endpoint that we needed to access into a central VPC and use Transit Gateway to get there. And then that just allows you to go straight out to Amazon services over a private connection. So again, no internet access. It's no dramas for us. The other cool one we'll put in there was the Sumo Logic. So it's a log aggregation platform like Splunk or Datadog, if you know those, but Sumo is what we use. And again, we've got a central place where all of our logs flow through the shared services network. So that was the problem we wanted to build. So we created our own sort of problem there. We've got lots of different stuff that we wanted to build. We had no chance of bringing that into our old environment. It was just not going to work. It's too much stuff to build. We're looking at lots of accounts, so 25 workloads potentially coming up. We wanted 4 environments, wanted deployment methodologies for all those systems that we got, the network that we talked about, logging, security, cloud management, all that general sort of stuff. So we're looking over 100 accounts like straight off the bat. It's pretty straightforward for that. I think we've got 80 odd now, so we're still expanding, but yeah, it's a lot more than what we had before. It's probably like 10 times what we had before. We needed to expand our dev teams to actually own each of those individual boxes. So we just couldn't have a central team to manage all these resources. It was just going to be too much for one team. So we needed to enable the development teams to basically own their entire system. So not just the development code, not just the code that goes onto the landers or wherever, it's the entire system. We basically give them free reign. And we went down that path just because they're the ones that actually know what these systems do. We're using serverless, so there's no risk of operating systems. We've got control over what they're able to access, so it's kind of weighing up that. The other one in that sort of area is the IAM stuff. So one of the biggest issues we've had previously is with IAM and giving developers access to create an IAM role. Because as soon as you have access to create an IAM role, you have free reign in that entire account. You give access to a developer to create an IAM role in a Lambda. You can basically do anything you want in that account. Because all you do is you create a role that says you've got admin access, you then create a Lambda, attach that role to that Lambda, you can then run whatever code against the entire account. So there's always been a risk of having a central account, and again, why we went down the path of separating all of our accounts into these little tiny things so that they've only got access to break their own stuff. The other couple here is the devs and cloud engineers. They've got different priorities and different strengths. So you're not going to go to a dev and say, hey, build me a network. It's just not going to happen, not going to happen well. They're going to have a EC2 instance on the internet with 0.0.0/0 allowed SSH. Many times I've seen that, many times I've hated it, so don't give devs access to do that. So we didn't. We did that in the platform. The cloud engineers have that. But again, similarly, the cloud engineers aren't going to be the ones that are going to respond immediately to, hey, my CPU or my Lambda is too slow. They don't really care so much. That's the dev's problem. So let the devs do it. And that's kind of where we wanted to go with this, is that we needed to let them do what they needed to do to maintain their system, but within the guardrails that we had to build to keep it secure and that we were comfortable giving them access to do all this. And this is kind of where the CDK stuff comes in as well, is that they build our entire systems with CDK. And again, to do that, you need access to the Amazon resources to build it all. So that was the problem that we've really created, and we needed a good platform to build. So I think, Levi, I think it's up to you to tell them how we did it and what we used.
Got a thing or two to say?
Yeah.
So before I go any further, I do just want to really highlight that I did not do this on my own, not a chance. We had considerable help from Journey One, specifically Praz and Craig on the floor with us throughout the entire build. But also considerable help from Christian at a high level, sort of coming up with some of these concepts and helping sort of flesh that out. From Todd Melville, giving us a lot of organisational help. And the remainder of the Brains Trust, as they're fondly called at Journey One. People like Paul Nolan, Ben Bowers, they've been phenomenal. So, landing zone accelerator, nuts and bolts, what the hell is it? Essentially, it is a no-code solution for managing AWS services. It can manage quite a large number. It was 35 plus at last count, and that is constantly growing as the LZA team build out that product. So it uses a code pipeline in the management account to basically take the YAML, of which there is quite a lot, transpile that into CDK, and then apply that across the estate. You can see a snippet of the YAML there. Now, I love this. YAML is my bread and butter. I come from a Puppet and Linux sysadmin background, so having YAML, declarative language to describe my estate and how it should function and work, gorgeous. Absolutely love it. So the intent of that solution overall is to provide an automation platform, something that conforms to AWS best practice and global compliance frameworks. So they provide, we actually used essentially a blank slate when we spun up because we didn't really fit into any of these boxes. But they do provide starting templates for a broad number of industries, from education, health, finance, and the standards frameworks that apply to them, things like the NIST cybersecurity framework, NCSC, HIPAA. A lot of it is fairly US-centric at the moment, but it is constantly growing and evolving. So what was awesome? Well, going from nothing to a full deployment was relatively painless. Relatively. It was thanks to the very clear and straightforward config. A lot of the challenges and difficulty we had, it was more in figuring out what we wanted to build, not getting it into LZA. Being 100% config driven meant that we were able to take a lot of what we wanted to do, have a crack at it in a completely separate organisation, our test org, build that out, try stuff, fail, blow it away, rebuild it from scratch because it's nice and quick, it's all right there in code, and once we were happy with that, take that, lift it, drop it into our production org with some minor config changes, and away we went. Really good way to iterate and develop on that infrastructure. Spinning up extra workloads. This can now be done by a single engineer in less than a day. Under our old platform, our old way of working, getting a new environment for an application to be built out into could easily take 5+ days. And this is not necessarily 5 days of an engineer just head down at a console, but due to the disjointed nature of all of the processes, all of the waiting, all of the context switching, it just could not get turned around in less than a week. It's very easy to apply CloudFormation templates via the customizations framework. So LZA gives us a way to drop in a CloudFormation template into our repo, reference that from within the YAML, apply it to either a single account or even entire OUs, and pass in all the parameters that we need. This has been essential to managing our custom logging solution and our bespoke DNS management solution, which I'll touch on in a little bit. Being able to spin up those consistent workload accounts with all of the guardrails and all of the fixings has meant that we can spin them up quickly and hand them off to the developers. As Liam mentioned, there's no way that we were going to give the keys to our kingdom to our development teams when everything that our business depended on was in that single account. That's not to say that I distrust the developers, but as a cloud engineer, I want to make sure that everything within my cloud stays running and operational. And lastly, pretty much everything is in one place. I think most of us, over time, if we've worked in this kind of environment, we see that sprawl begin to happen. We know that, suddenly, actually, you've got to go look in this repo that's over here that only Bob knew about. So having everything contained within that single repository means that you have essentially your entire infrastructure versioned under one commit that you can look at and know this is what it looks like. This is where everything is. So what were the challenges? Well, the price you pay for having everything in one place is that everything is in one place. We have over 15,000 lines of YAML in our LZA config so far, and that is only going to increase. This poses some challenges when we're onboarding new developers, when we're trying to bring other people in to help me support this solution, because there's just so much to it. There's so much to take in. Still better than the alternative. If you're a VS Code user, you might appreciate just how tiny that scroll bar is on the code map on the right there. It's hefty. That's actually from our network config YAML, which is just over 12,000 lines. There's been no template tooling provided with LZA. Now what I mean by this is that there's no way for us to define a set of defaults for a resource. There's no way for us to quickly stamp out numerous like-for-like resources. Say we want to spin up 5 accounts, well, we can't just say give me 5 of those, we actually have to copy and paste that account block 5 times, make those tweaks. This does make it difficult sort of over time as we change how we're managing these resources, as we realise that we might not have made the best decision in some of our parameters, and we wind up with one version up here that's configured one way, another version down here that's configured a completely different way. We have used sort of wiki documentation and inline template blocks, just commented out chunks of YAML as a copy-paste template to mixed results. It still can be a little more convenient to just go quickly to the last one you deployed because you know that one worked. Copy that and away you go. And when you're under the pump, you might forget to go back and update your templates. DNS management has been our most impactful gap by far. It did require us to build a fully bespoke system to manage this. Now, I do want to call out that this isn't necessarily a failing of LZA. This is simply a challenge when you're dealing with runtime resources. When we build out our accounts and our networking, we know, what that base looks like, but we don't know what values are going to be needed for, say, the private API gateways. What are their records going to look like? I have no idea. The devs haven't deployed it yet. So we needed a way to provide them a way to essentially self-service that DNS capability. Now, this was a lot of work to put together. Big help from Craig and Praz on this one. It essentially needed a way to spin up private hosted zones, associate them with the correct accounts, know which accounts were the correct accounts, and then provide a way for the devs to service that themselves, but also understand when things went wrong and they perhaps provided an incorrect value, what happened to their DNS? So there's a lot of moving parts to that, a lot of SQSQs, lambdas, and cross-account permissions that we had to build out just to cover off that gap. And validation of all of that YAML. It's one thing to do a basic YAML validation, to know that it's valid YAML, but it's another thing entirely to make sure that it's valid LZA config. Now, we initially simply relied on our code pipeline, because there is a bit of validation that occurs once the pipeline attempts to apply it, but it takes about 15 to 20 minutes from pushing your commits to that validation running. When we started off, I'm sure everyone's been here, it gets to the point of the code pipeline, it fails, and you go, crap, okay. Oh, that was a simple mistake. I won't make that mistake again. And then you make a different mistake. And then another different mistake. And the guy sitting next to you, he wasn't watching, so he makes the same mistake. And now you've lost days of engineering time. And that's essentially what happened to us. It took quite a while for us to realise, hang on, this is actually a bigger problem than we realise it is in the moment. And eventually we were able to reach out to the LZA team, and they were able to provide us a way to run the validation that occurs in that pipeline locally. So now we can actually do that before we push it to our feature branch and merge that to main and push it into production. Great idea. Now, what would I do differently? Firstly, I'd be a lot more selective about what we are managing with LZA. Now, I spoke earlier that I love the fact that everything is in one place. I kind of lied a little bit. We did yank some of it out. The big thing that we pulled out was actually our SCPs and our guard duty rules. When we attempted to manage all of our guard duty rules and SCPs within LZA, it actually took the pipeline run from a couple of hours out to several days. Less than ideal. When you're under the pump, you're trying to build out this big, new, shiny platform. You've got 3 engineers all trying to do different things and work on different parts of it, and nobody can deploy anything for 3 days. Now, once we yanked that config out, it dropped straight back down. We do manage that in a separate repository now, but because it's so much more static, it doesn't change anywhere near as much as the rest of our estate. We figured that was a fair trade-off to make. I would plan and build a more centralised sort of DNS and certificate management system. As I mentioned before, that DNS management solution worked well for us initially because we were working with a certain set of assumptions. No plan survives the battlefield. Over time, we've realised that there are actually more use cases that we needed to deal with. There are more runtime resources that we needed to deal with. We hadn't factored in that we might need to provide a way for developers to generate certificates and authenticate them and validate them. We simply hadn't done it. So as we continue to come up with these new requirements, we realise them, we walk that fine line between sort of being agile and this bespoke solution turning into a big ball of mud. A more centralised and modular system for those runtime resources would cover off all of our existing use cases and give us a more concrete foundation for building out those future use cases. I would have built that templating system from the start. Even something as straightforward as a simple script to take in a few values and spit out a whole config block would go a long way to reduce even further that lead time for building new accounts, and significantly reduce the complexity for allowing some of our other engineers that haven't been here for the entire journey from the start to jump in and start provisioning those new accounts and new resources without requiring all of the domain knowledge that I've built up. And lastly, I'd have invested a lot earlier in building out that validation pipeline. As I said, this cost us days of engineer time, and in retrospect, it seems blindingly obvious that we should have done that. But as I said, in the moment, it's always just, oh, it's one small mistake. What could it cost us? So in conclusion, we have been on the cloud for a long time. Our environments became more and more complex as we kept piling stuff into our central managed account, which was essentially treated as data center in the cloud. Just put it all in the data center. At the same time, our customers, as always, have constantly growing and changing needs, and we needed to keep up with them. So we had a lot of challenges to solve, and Liam and the Brains Trust there sort of developed that new tech strategy, which called for an entirely new approach. Ways of working that we simply hadn't done before, and we needed a lot of help to figure out what that looked like and to enact it. So we adopted LZA along with some other tech to help reduce that sprawl and enable a more streamlined way of working, both for our cloud engineers, but really for our development teams. They've really gotten the short end of the stick in the past when it came to building our applications, keeping them at arm's length from our infrastructure, kept us safe and warm and fuzzy as cloud engineers, but didn't really accelerate a whole lot. And now we've learned a lot, and we've come out the other side with a rock-steady platform that lets our development teams focus on their strength, developing. And thank you. Questions?
Yeah. Sure. Yeah.
On the page 18, if we go back to page 18, there will be a huge YAML.
That'd be one of mine.
And,
No, this one.
Oh,
my
that one.
understanding that this YAML represents something which landing zone application, which Christian was talking about earlier. That's the input for that.
Yeah, absolutely.
Do you know what comes out of it? Because I think that there is a limit on the 500 resources provision. So I'm just knowing that it is 15 kilobytes of something. There should be more than 500 resources provisioned on the other end. So I wonder how it is working with a single stack, or how does it break things into the stacks and things like that.
So this is not CloudFormation. This is bespoke sort of YAML that is specifically for LZA.
Okay. But do you know what comes on the other end?
From what I understand, it transpiles into CDK and then applies that CDK from there.
It gets over the limits by actually applying the CDK in the target account.
Right.
So not at the org level, where the limits are sitting on the smaller accounts where it's only kind of spinning up maybe 20 resources or 30 resources.
I see. Thank you.
Cheers, Press.
So the YAML, just to understand right, so the YAML is your base configuration that gets translated into the CDK.
Yep.
And then the CDK applies the actual changes.
Correct.
Okay. And then each team manages their own section of the
They manage a completely separate repo. So what LZA is the platform underneath, and then what we've done is we've allowed developers to build their own CDK app sitting outside of it, and deploy it into the platform. So the LZA is just that platform sitting underneath, and then blocks on top are what the developers build in their own sort of way.
But they developed to use CDK then?
Yeah, we're running them with CDK because it's a really easy way for them to develop the Amazon resources.
Yeah.
Yeah, so they don't use LZA at all in the development teams, they're just building their own CDK apps.
Okay, so then this is sort of the orchestration part of it.
A little bit. So the way they actually get their stuff into the platform is through a pipeline through GitHub. So we give GitHub access to deploy into certain accounts, and that's how they run it. So they commit to GitHub, and then GitHub will push that CDK out into the platform, into that specific account, and that's kind of where they go from.
Okay.
Yeah. So you guys, does AWS have anything like AI to help you find stuff on that YAML file, 15,000 lines? So it's pretty good at try and say find whatever. And then
Unfortunately not, but who knows, maybe we'll try and fine-tune something to to help me out.
We hook your brain up
means
to
that you
Amazon.
cannot lie, or not means that you were successful. What does no means? You didn't try? Or did you try?
I haven't tried to build any AI into this yet.
I was downloading a torrent file, and then some weird file came, and it was like some HTML and stuff. Right? I'm not very familiar with it, so I just ran it through the Edge Copilot, and it came up with some summary about this what it was. And then there was like a get something, and then I went to check up on the domain site, and it said like something's like unsafe or something. So something like that, simple, just maybe something as that.
Yeah, I expect if you fine-tune a decent code-capable language model on the LZA documentation, you'd get something that would get you quite a long way.
It's probably worth noting that the genesis of the LZA solution is with AWS professional services. So they actually commissioned this in order to accelerate their deployment of large landing zones for clients. The fact that it's not a full-blown service but a solution that's now open source but fully supported is particularly notable. But what is also notable is these guys are basically outside of AWS ProServe, they are globally leading in the adoption of that solution. There aren't too many. Although it's probably changed in the last few months, but certainly when we started a year ago, it was one of the few large deployments around the world.
Yeah, we've definitely wrinkled the LZA team's brain a couple of times with the scale of what we're managing.
And as a result, the LZA team have obviously they've been focused on functionality, stability, not on development tooling. So there's obviously huge scope to improve the engineer experience here, but that's probably another iteration or two down the track.
Page 13, please.
Sure. And you got us indexed.
Well, that's
what it is, yeah.
one behind. 12.
12?
Yeah.
Oh, yeah.
These lambdas, I don't know, maybe it is my vision, but from what I can see from here, from this chair, that these lambdas are sitting outside of the VPC.
No, that's just not shown. So every lambda that sits in this setup is within a VPC.
Okay.
Yeah, and that's how it uses the transit gateway to get out. Yeah.
Hi. Great presentation, by the way. Thank you.
Yeah, thank you.
Yeah, just a question regarding the IAC. I mean, it's mostly IAC, but the thing I always learn about IAC or when platform engineering is that you're like, okay, I'm going to give this to the developers, and then it's all good. And then a week later, you realize that, oh, I actually put in a 0.0.0.0 on my security groups. So now I have to patch out like this IAC to the ones that were already deployed. So how do you manage to work on probably 15K lines of code, or maybe on other resources that you do as well?
So that's one of the nice things about LZA. It is everything all at once. If we need to make an update, we simply make that update, and it takes all of our LZA config and applies that. It validates what exists, what's out there, and then reconciles those differences. So we don't need to do anything any different from deploying just a regular new change to account for that.
One of the key differences we've done is completely separating our workloads from our platform. So in the case of someone's opened up a security group, it's depending on whose security group it is, because if it's the LZA one, we can just let the LZA guys to go through the YAML file and update it. But if it's one that the developers have actually created, it's on them. They can basically go in there and do what they need to do to get that security group right. And that's where things like the guardrails that we talk about come in, where we're monitoring security groups for a 0.0.0 access, or we're preventing them from creating iron rods with start. So there's those two sort of aspects to it, where you've basically got to monitor because you just can't prevent certain things if you're giving them the keys.
Yeah, something we didn't really sort of explicitly detail through this is that the workload accounts that my team provisions are essentially empty accounts. They've got a VPC, they've got some basic networking, and they're under all of the guard rules and SEPs at the organisational level. But past that, it is, as Liam said, it's on the developers. That is their playground. As long as they fit within the security guidelines that we've set, I don't care what they do, and I'd like to keep it that way.
Same.
Expanding on that, so are your developers allowed to make like ClickOps changes in these accounts?
No, they actually don't have any ClickOps access. So they do have read-only access. They do have read-only access into their development accounts, which enables them to play around, to go in and look at things and see what they're building. But as soon as they're done in that development account, they can't log into any of the other environments. They can't actually get console access to UAT, SIT, or production. It has to be all config as code.
All CDK. Yeah. Basically, they just commit and that's what they do.
That's probably the most impressive.
Yeah, the biggest challenge for us was the IAM stuff, and because of the network design, because of the separation, we've been able to give them that.
Just elaborating on that, so does that mean that all the development is done locally, tested locally? You've only got read access to the account?
They've got sandbox accounts that they can play around in to deploy the resources, but other than that, they'll have their JavaScript stuff running locally in Node as well, so you can do a bit of both.
Okay, cool. Awesome.
Do you think any heuristics on the other side to model and manage with OZA? Like,
Sorry, I didn't quite catch that.
like any heuristics around the upper boundaries of the landing zone you might want to manage with OZA?
Not that we've run into.
Do we like that sort of limits increase?
We did have to get the account limit increased on AWS orgs, but that's not necessarily an LZA limit. That would have happened if we'd spun them up by hand anyway.
One of the main challenges with LZA is the time that the pipeline takes to run. So a lot of the special source is in that pipeline. That's how we manage to deploy so many resources through its distribution. That's how things get validated. It's why we don't have to worry about an individual change. It's just everything all at once every time. That is a known concern from the LZA team, and at some point they'll be putting in time to reduce that. There was a very interesting announcement about CloudFormation just in the last week, I believe. So they're now no longer waiting for the eventual consistency on resources to come in before they start creating dependent resources. So depending on the resource, they're spruiking perhaps 30 to 40% speed increases on CloudFormation deployments, which is interesting. But yeah, it's definitely that pipeline.
Like with an out of the box of the pipeline, 30 to 40 minutes per run, and what sort of times are you seeing?
We're up to about an hour and a half to 2 hours for a standard run at the moment in our production org. In our test org, it's still down about 40 minutes.
Yeah, just for frequency of those kinds of changes.
Yeah. Yeah, and again, it depends on how much is changing, because as soon as it has to start actually altering resources, that time goes way up.
What's your ratio of cloud engineer to developer, and who does your production support?
Well, at the moment, the cloud development is me. Previously it was myself, Praz and Craig. So there's three of us. How big are our development teams? We're Getting fairly hefty now.
Doing the platform stuff, you're probably talking 15, 20. There's like 2 squads, I think, working on the platform stuff, which is building out the workloads in this. They are supposed to be doing the prod support. So basically they own the entire system. They've got access to do everything they need to do. They get the logs out of it through Sumo. They get the visibility to do it all. So it's effectively on them to do prod support. Otherwise it's Levi on the platform at the moment.
Yeah, if it's a underlying infrastructure concern, that's my problem. But when it comes to the applications, that's all them.
Yes. And it's just worth pointing out as well that this is our new platform. The old platform has not gone away. So when you talk about that, that's a slightly different ratio. And again, we had we had a few more cloud engineers looking after that legacy platform. That's exactly the issue we had, right? That ratio you talked about, and we were a bottleneck, even with more cloud engineers and that team looking after that platform. Now we have, at the moment, one. We will expand, but we've got one senior cloud engineer looking after it, and I'm able to really share that.
I'm not allowed to cross roads on my own.
Yeah, exactly.
So we've got time for just one more question.
Okay. So that big application which all other little applications depend on, how do you, is it like still separated from the developers? Developers are not allowed to touch it?
Yeah. Yeah, they only get access to deploy their stuff into those workload accounts. Okay. They have no access to anything underlying. So none of the LZA config, none of the accounts involved. We've put a lot of work into building out the plumbing so that they don't need to do that. Things like our logging aggregation, which also supports application tracing, ships all of our CloudWatch logs, all of our Lambda logs, all of the tracing out to an external platform. So any troubleshooting they need to do with some of that underlying platform infrastructure, they can do themselves through Sumo.
Thanks.
Okay.
Please join me in thanking these champions for just quickly, in terms of updates and things coming up, end of this month, build an automated video monitoring system with IoT and AI/ML, one of our craft workshops. We are at capacity right now, but there will be a secret release of extra seats happening very soon. So if you are interested and are not RSVP'd, get on the way to this in the next 10 to 15 minutes. We haven't publicised it yet, so you're the first to hear. Our April session is open source on AWS. We've got an international guest speaker from AWS who will be talking to us on that. It'll be on the 23rd, which is a week or so later than we would normally run, but we've had to do that in order to secure that speaker. Again, nobody else has heard this yet, but we are working towards the next workshop being a security jam, which is an incredibly fun, gamified security exercise. Had it in the works for a little while. We're getting a lot closer to it being a thing, so stay tuned. A couple of my good friends and colleagues, Rami and Ben, who are here tonight, delivered an excellent workshop called I'm Bringing Hexy Back at Latency last Friday. They're very keen to deliver that to our group. Sorry?
There might be an encore coming.
Encore, indeed. So, again, date not locked in, but I'd be looking at that for some time in that kind of June, July-ish kind of time frame. We also have a Women Who Cloud session in the works. We're pretty keen for any input, particularly women, might have about what they want to hear in that. So please, anyone really, if you've got some suggestions, the usual channels, DM us via Meetup or LinkedIn or what have you. And we will be sorting that out for some time in the coming few sessions. Lastly, good friend of ours, Donna Edwards, has asked us to spruik the Insight Awards. They are a local innovation, IT innovation awards. They've been running for a long time, 30 odd years, I believe. The winners in WA get elevated to national and international competitions. So there is the site, I believe, is insightAwards.org.au. You can nominate, I believe, yourself or anyone else that you believe, any other teams. So the categories are research and innovation, startup of the year, social impact, innovating government, transformative solutions, and the Peter Fillery undergraduate tertiary student project of the year. There's also some personal awards for Achiever of the Year, Digital Inclusion, and the Tech Company of the Year. So that is coming up for 2024. Please nominate anyone who you feel is worthy. On that note, does anybody else have any urgent kind of community announcements? No? Because there's absolutely nothing going on, as you can hear. Thanks once again for everyone for turning up, particularly new people, and we hope to see you again next time.